I presented some time ago, and there was some interest in getting more information on some of the trending. And so I'm, unleash Kevin on many of you tonight. You will not meet a more passionate person about air quality trends. So our presentation will be a little bit heavy on that, but we'll, hopefully it'll be very helpful. I think we have a lot of slides, a lot of information. We'll just make sure we pause appropriately. If I'm comfortable pausing for questions and dialogue throughout, if that works for everyone else. And we can kind of keep an eye on the chat line as well. Or we can wait till the end. Okay, so I'm Gary. Kevin's online. Kevin's driving it. Kevin, I guess we'll move to the next slide. Okay, so pretty obvious thing there that air pollution is really a big deal, and it comes from all sorts of different sources. And it's just a slide we show in some of our educational materials to say it really is the biggest threat to human health. And you can see the numbers by the World Health Organization, World Bank. And we have a fun little video. I think it's like a minute long. And Kevin's going to try to launch this thing, and we're going to see if it works. The problem is that it hits a different...
There's a lot of stuff in our air.
We can hear
some that we need, and some bad. Pollution's the bad stuff. But what causes pollution? Heating.
And I can't hear you either because you're on mute.
You couldn't hear or see the video?
No, we could hear the video. We couldn't see the video. I think it probably went to one of your other monitors.
Actually,
that's the problem with Zoom. When you launch something from the application, it goes to a different monitor if you have multiple monitors.
That's the thing. I tried to put it right on top of the same monitor.
Oh, did you? Oh.
Yeah.
If it doesn't work, it's not the biggest deal.
I'm going to stop sharing that one, and I'll see if it starts up again. I might have to do this again. Can you see the video now?
We can, yeah.
Okay. I'm just going to back it up.
There's a lot of stuff in our air. Some that we need, and some bad. Pollution's the bad stuff. But what causes pollution? Heating and cooling our homes, driving cars and trucks, and making the things we need. The weather affects pollution and moves it around. Pollution can cause health problems for many people. And it hurts plants, animals, and the environment. If we help by using less energy in our homes, schools, and factories, ride the bus or our bikes instead of using a car, we can reduce air pollution. Alberta Airsheds organizations play an important role in keeping our air healthy. Check out our website to find out more. Let's all do our part to keep the air we share healthy.
So it's a video that's geared for younger crowds usually, but I just thought we'd start off with a little fun video. Okay, so Kevin will get us back on the PowerPoint, and the next slide just talks about what is an airshed, just so you know who we are. So the Alberta Capital Airshed, we are a not-for-profit society, and we are about 14 years old now. Our role is to be neutral and impartial in the area of air quality. Our interest is only knowing what the air quality is and sharing it. So we actually have multi-stakeholder membership and governance. So on our board, we have NGOs, we have community, we have municipalities, health, industry, sort of everybody that has some stake in what the air quality is. And our funding actually comes from members are charged fees, and we also apply for grants. So we don't have any actual core funding that's given to us by any sort of body. Our primary mandate is to monitor, analyze, and report on ambient air quality or outdoor air quality. And we play a sort of secondary role about trying to raise awareness. So we do a lot of school education as well. We are one of 10 airsheds in the province. And Kevin, I hate to ask you, but there's a second video there. I promise this is the only videos I brought. I just realized.
What is an airshed?
We're gonna have to do this. Sorry. I promise there's no more after this.
That's why you asked me to drive.
Yeah, no kidding. Yeah.
Can you see the video now?
Yeah, we're good.
Shed. There are 10 regional airshed organizations in Alberta. Airsheds are important to have in our communities because air pollution poses the largest environmental health risk to us. The health risks include breathing and lung problems, heart conditions, and increased risk of stroke. Airsheds keep an eye on local air quality by monitoring air pollutants and by measuring weather conditions. They report and share this data with governments, Indigenous communities, academics, the public, industries, and other interested stakeholders. This information is also used to determine the Air Quality Health Index, which lets us know if the outside air poses a risk to our health. Alberta airsheds inform decision-making, teach the public about the importance of clean air, and work with the communities they're a part of. They're a vital contributor to managing air quality. Learn how you can get involved with your local airsheds by visiting our website, albertaairshedscouncil.ca.
Okay, thanks, Kevin. I promise no more videos. Good. Okay, so that's just about who we are as the Alberta Capital Airshed, and you'll see you'll see a little map there, but that's fine. So we are Greater Edmonton. Oh, there it is. Okay. So why we have such a strange shape is because there's existing airsheds on both sides. There is one in based out of Fort Saskatchewan with heavy industry called Fort Air Partnership. And actually the original airshed of the province is west of us, called West Central Airshed. So what was left was carved out to become the Capital Airshed, and it was sort of after the fact, just so you know why it's an odd shape. Air does actually move freely past those borders. Okay, next slide. So Kevin, do you want me to keep going, or do you want to talk about that?
You're doing a great job.
Okay, great. Okay, so this is sort of what we're going to talk about this evening, which is, I warned you, a little heavy on the data and trends. So a little bit about how we collect the data that we know. What do we monitor for? Where do we monitor? Really, what's the current data? What's the trends? What do we know about the ambient air in our community? How do you get access to data? And then a good amount of time, hopefully, focused on news sense, citizen science, and that sort of thing. So engaging how people can engage a bit more at the community level. Next slide. Oh, okay. So the picture on the right you just saw in the video, basically, so that's the 10 airsheds. And if you're curious, in the white space between the airsheds, we don't have air quality problems. No, I'm kidding. We just don't have airsheds formed. So they are formed at the local level and sort of expand out into the area. So there is some talk about a couple of new airsheds growing to fill those spaces, but at this point, there isn't one. In the top left is a little diagram, and it talks about who is responsible for air monitoring in the province. So there's really different types of monitoring, but there's 4 players. So the Alberta Environment and Parks, the provincial department, does do community and regional monitoring on their own. So they have, I think, 8 stations around the province, mostly urban stations. The airsheds are next. We have, and I don't know the exact number because it fluctuates a little bit, but it's around 75 stations around the province. And so we do a variety of community and regional monitoring. There's a couple of near fence line, which means close to large emitters, industrial emitters. ECC, Environment and Climate Change Canada, also does some monitoring. They do it in conjunction with us mostly, so often at the same stations. And then industry itself has to do some monitoring. Heavy emitters are often obligated within their license to operate to do some own monitoring through some rules with AEP and submit the data that way. So just 2 pictures of monitoring stations, just to give you a look at 2 different ones. The one on the left is St. Albert. It's very pretty. It's very colorful. The one on the right is actually a community league hall. It's Woodcroft up by the TELUS World of Science. And you probably can't see it, but our equipment is on the roof of that. So we don't have a separate building there. For some reason, Julie, you sent me, oh, there it is. I can't see the messages very well. Okay. Okay, we can talk about that later. Okay, next slide, Kevin. And that's over to you.
Perfect. I have to apologize, everyone. I can't see the comments right now. I don't know if it's because of the way I'm sharing. So if there's any questions or that, please flag me down somehow. If I'm looking, if I'm looking at the right screen. I just wanted to show a quick snapshot of what we typically call the traditional monitoring. Fixed reference methods, FRMs, is one of the things. And this has been something that has been monitoring for quite some time. It's typically a small trailer or a small unit like an air pointer or something like that. And you have these blue boxes inside these trailers monitoring for all the different air pollutants. This has always been the mindset of the traditional monitoring. We'll see where this is moving in the future. The one thing that we often talk about is that if it's a traditional monitor, we often think it's good data. And that's just the question that we raise. It's not always good data. There's sometimes it's good, sometimes it's bad, but you have to have a good sense about what you're seeing for the data. So where are things housed right now is another question that we have. Is our data easily accessible? And I'll step into some of that as well. What drives our monitoring is probably one of the biggest ones. So often it's due to a permit condition, an operational license, some condition that's given by the provincial government to monitor. Other times there's data for decisions, like we need some background information. For example, when a ring road is done, they'll often want 6 months of monitoring for a particulate matter before even ground is broken, because they want to know what the background is and then what it's going to be like after traffic starts on it. So data is collected for a variety of reasons. But the one thing that we learned is that if we collect data, and I'm putting an academic hat on now, we ask more and more questions. Every time there's something that happens, we want more data. And when we want more data, we often want it faster. We want something very rapid for that kind of information. What do we typically monitor? We look at the criteria air pollutants, is what it's often referred to as. So our sulfur dioxide and nitrogen dioxide, these are our traditional ones that we've monitored for quite some time. And the reason for it is acid deposition. That was one of the big drivers at the time and why we collect that information. Carbon monoxide is another one, ozone, hydrogen sulfide, of course, and then we have our VOCs, or volatile organic compounds, that we look at. And that gets into a whole speciation of data. We can have a lot of VOCs. In fact, the typical scan of a VOC is 156 compounds. So we go through all of these ones, and you can imagine the massive data set you can get after that. Our particulate matter is another one, and this is similar. We can either get just a particulate matter reading. So if, for instance, we're curious what's going on during wildfires, we want to know what the PM2.5 reading is. But we can also do a scan of the PM2.5 for metals. And we want to now know all the 65 metals that are done on a traditional scan. What's comprising of that particulate matter. And then, of course, all of that information is I want to say, useless without the meteorology. Because if we don't know where it's come from or where it's going, it doesn't help. So we want to know our wind speed, direction, temperature, precipitation, all the fun things, even solar radiation, which isn't collected in very many locations, and but it's an important parameter to see. And there's a whole bunch more meteorology that we can collect. Where are we doing it? As Gary talked about, 89 stations throughout the province. Most of them are within the airsheds, but there are a handful that are just outside of the airsheds until it's filled in. Just a quick snapshot. This is what Gary was talking about at the beginning. Alberta Capital Airshed, of course, is in the center, and Fort Air Partnership is to the north, and then West Central is to the east. As we can see, the dots just indicate where the monitoring locations are at this point. And so these are the monitoring points that we have laid out with the fixed reference monitors, with our trailers. So where's our corrected air data collected? There will be a test at the end of this, just so everyone's aware. So where is this data collected and stored? We've got the Alberta Data Warehouse. It used to be the CASA Data Warehouse. And I think when they used to have statistics for that, and Matthew would know this for sure, is that I think I normally had, I did about half the downloads for the province, I'm pretty sure. And so, but right now it's on the Alberta data warehouse is where it's migrated over to. The two that I tend to attend the most is probably the National Air Pollution Surveillance, the NAPS stations, and the National Pollution Release Inventory, the NPRI. What those two are is for the entire country. So we have all of the monitoring stations throughout the country and all of the emission points throughout the country. And it'll make more sense once you start to see some of the data that we collect from this. And so here's an example of the 2018 NO2 NPRI data. So all of the dots that are in blue indicate all of the locations of an emission source of air pollution. And then the heat map, I've just married it in there just to show you what the NO2 profile looks like, where are our hotspots, and it's just in the province. Even though the MPRI data goes out into the BC and Saskatchewan and into Manitoba, I've only done the heat map for Alberta. Because if we did it for everyone else, you would see Vancouver light up pretty high as well for NO2. But just from this perspective, when you see it, and where I'm kind of showing you this is this is the 2018 data. And so that's the most recent data that we can get. Marry it with the 2019 NO2 data that we collect in the province. And there's many more stations that are on here. I was trying to show Gary, but I had to squish the figure up quite small. But we compare all of the NO2 monitoring that's done in the province to everyone else, just so all of these stations that are collecting it, we want to see where things are laying out. So right now our hotspot in the Alberta region is in the Edmonton zone. Part of it is that you have to bear in mind is that the hotspot that we see is because we monitor. So where we have other areas in the province where it looks like it's absolutely spotless, it's because we don't monitor there. So we actually don't know what the data is. And so we only know what we know from the monitoring. We do the same thing with our SO2 profiles, and we can see where that stands out as well. All of our emission sources, and then married with the heat maps, so we can see where our higher concentrations of SO2 are. Put that on top of where we actually monitor, and that's actually SO2. There was a mistake in the slide. So it's the 2019 SO2 measured profiles. So we see again two major hotspots, one in the oil sands region and one in the Edmonton region, just south of, and we also have a small spot so in the Leica region. We move into the PM 2.5 data, and again, this is the emission profiles that we see, and then we put it on top of our actual measured data. So we start to see other areas that are lighting up, but often we'll start to hone in on the same typical areas in the province where we see hotspots, and we start to look at it more closely. Let me know if I'm going too quick or too slow. Okay. I actually started with 199 slides and I cut it back a little bit. And so the whole reason for doing a lot of this is to collect the data and put it into a form that everybody can understand. And it started with an AQI, an air quality index, and it's moved to an air quality health index. And I'm sure everyone has seen the 1 to 10 scale for the AQHI so that you can identify where the conditions are. Gary has talked about the Twitter feed, or no, you didn't talk about that one, did you? We have the forecasted Twitter feed.
Yeah, sorry. So the Twitter feed actually does a forecast, so we can actually forecast what the air quality health index is, because as Kevin mentioned before, it's sort of so when we do education in schools, we talk about pollution plus weather equals air quality. So we marry the pollution data that we have with weather forecasting, and so we can actually do a sort of AQHI forecast for the day. We can sort of see what we think we're going to be, and also it'll actually automatically change as we change numbers on the index as well on the Twitter feed automatically. So, and that's for Edmonton, St. Albert, and Sherwood Park.
So with that AQHI, we often have that low, moderate, high, and very high. And I'll explain a little bit more as we get into it. But obviously nobody wants the very high because it would indicate something's really wrong in the atmosphere. We've got some issues going on. Most of the times we sit in the low and to the moderate. And just a quick snapshot of the data that we see in the province. And so this is just across the province. And you have to bear in mind this graph actually starts at 82% and goes from there. So most of our conditions are in that low risk for the entire year. This is the 2019 data set. Once we move into the moderate risk, we have a low percentage, again, sometimes less than 10%. But then once we get into that higher risk and very high risk, that's when we start to wonder what's happening and what were the conditions during that. I honed in just a little bit when we looked at the ACA region, and you can see right there where we've got low, moderate, high. So we're sitting at about 88% of low for Edmonton. But when we get to that very high, you're looking at about 0.1% of the times. So that 0.1% of the times it indicated it was very high. If everyone remembers back to the end of May last year, that was the wildfire event that smoked out Edmonton pretty bad, well, most of the region. And then of course there was one, and I've only seen it once in another region, actually it was in Grand Prairie, where it sets off a very high indication when fireworks is used. And often it's kind of one of those ones that you look at it and you go, why do we get a very high? And then you look at the date and time, and it's either Canada Day or New Year's. And so those are the two that we often see.
We also get, Kevin, we also get wintertime smog events for sure with immersions. That's probably the other time that other than wildfires, that it really goes up. Probably just want to mention too that the Edmonton number is actually an average of 4 stations. So east, downtown, Edmonton South, and then the station that I showed you in the community center at Woodcroft as well. So those 4 stations actually provide data, and then it's averaged together. In Strathcona County, there's 2 stations, one in Sherwood Park and one in Ardrossan, and then St. Albert is just 1 station.
I left off the calculation for calculating it, Gary, but if you want to go into it, we can.
Yeah, that'd be great. That'd be fun. Yeah, people would like to hear that. Yeah, no, it's a really. So what I would say though is that it's the criteria pollutants, and then if one gets really high, like particulate matter, because it's a forest fire, the others are sort of thrown aside, and it just becomes focused on that one really problematic pollutant. So in other words, the ones that are not a problem won't bring down the number. That's probably important to say. So it'll carry the wave. If there's a high wave of any particular pollutant, it'll carry that wave and show it that way.
And it's important to note the AQHI is actually calculated on a 3-hour running average. So it is smoothed out. If we have a spike, we sometimes get it smoothed out from that period. I had to throw this one in just to be on the safe side. And so, is there any other data geeks like me? Okay. If not, you can go get a coffee or something. I should be done in a few minutes. So I'm going to get into the statistical analysis of all of the NAP stations in Alberta. No, I'm just kidding. I just threw this one up just for entertainment's sake. To see a box plot and all the outliers, I was told afterwards that I showed a box plot several times that nobody likes a box plot. And so it kind of broke my heart, but I thought, okay, I'll move to something different, more entertaining and more color. So one of the things that we'll want to look at from a long-term trend perspective, and I do this kind of from a forecasting perspective, because other than just playing with numbers and being a nerd, I actually am a hardcore programmer. So I actually do artificial intelligence programming, and I look for patterns in different things and see if we can forecast it. And so you can see from some of these perspectives, there are patterns that stand out in it year over year, because this goes back to the year 2000 all the way to present from the Edmonton East Station. And I just picked the Edmonton East Station, mostly from the history that we have with it. But you can see from the perspective of the ozone, from our nitrogen species, we have a very recurring pattern. Some of the other ones, we don't see it as much. The particulate as well, it can stand out in certain events. If we keep focusing in on just one parameter, so now we're at the Edmonton East Station and we're just looking at those NO2 values, we start to look at what's actually happening. And the one thing that we've noted is that as time is progressing, we're seeing a declining peak of our higher NO2. Some of this is actually, we've done these studies before at a couple places, and it's been newer vehicles. As we change our vehicle fleets over and we're getting to newer vehicles, we have better emission controls. That's been probably one of the bigger ones that we see. And we try and classify that by saying, okay, let's look at the weekly and monthly profiles. What do we see from nitrogen species? Often it's higher in the winter. So In the left-hand side, we see the January, February, March, and then of course, once we get into October, November, December, our nitrogen starts to increase again. In the summertime, it's often low. We can put that into home heating, we can put it into vehicle idling, we can put it into a whole bunch of things. One of the things that we want to do, and I actually wanted to show Calgary data because it really stood out, but Edmonton East actually shows out as well, is that as time has progressed, we can break the data into decades to see, are we seeing improvements over time? And the one thing that's nice is that once we get into data after 2010, we see that drop that's happened. So it's not a huge drop, but it is enough of a decline that we don't want to see it going the other way. It'd be more problematic if we started to see it getting higher and higher as we're going through. But sorry, Gary, go ahead.
Can I interrupt for a second? Sorry. First of all, just to let I'm watching the comments, and there you have some box plot groupies. There's a significant number of people that like box plots. I don't know what to say. Anyway, but I missed a comment or a question actually from Sandra earlier, which goes back a number of slides, but I'm just going to throw it out there so it's there. Can you clarify what the emission profiles are, in brackets, the dots versus the hotspots? Are those the monitoring locations?
Oh, okay. So all of the emission profiles that we have, so say for example, for our nitrogen species, we may have 1,000 emission sources. So those are emission sources that are reported to the federal government under the National Pollution Release Inventory. We take all of that data and then we put it into their locations, because we actually have it all geolocated. And then we look for the high concentrations and we see where some of those hot spots are. Then we kind of push that off to the side and we put the monitoring stations in there. And then we look at the concentration and averages of the monitoring stations. So often we'll look at the averages, but then we also want to look at the profiles of what's the 95th percentile, 98th percentile, different percentiles. Are we increasing, decreasing, different statistical tests? And I know I talk to Matt about statistics all the time, so he's quite happy with that. Sorry, Matt. So those kind of things are where those profiles come from. Does that make sense? Because it's two different hotspots. One is from the monitoring and one is from the emissions. And so we kind of want to see that they're actually on top of one another. That would be the ideal, because then that means we're actually monitoring where the hotspots are. And in some locations, we don't see that. I know you have the slide deck after, so you can flip through it after, and if you have questions. I've got Gary's email on there. He can answer anything. So.
Yeah, we'll have to apologize to the box plot fan club that we only had one slide of that. But anyway, back to your presentation.
Okay. Sorry, I still can't see the comments. So yeah, if there's more, please jump in.
I'll watch out for them. It's okay. I got it now. Yeah.
Thank you, sir. So, moving forward, so one of the things that we'll look at is there's different trends that we can do to look at dropping profiles or statistically significant profiles. Seasonal Kendall tests, a Thyssen test, things like that will give us the ability to look at it and say, is there a decrease, an increase? What are we seeing? So we tend to try and remove the seasonality effect from it, so that the peaks and valleys that we see throughout the year, and we want to just be able to see, are we decreasing or increasing? And that's one of the things that we see from the left-hand side, from the 1982 when we started monitoring at Edmonton East up to about 2010, we had a statistically significant decrease. So the numbers at the top, what you see there, is it's showing that it's decreasing at 0.33, and so the units would be in ppb per year, and the 95th percentiles around it is that negative 0.42 and negative 0.42 and negative 2.4. Those are the bounds from it. So what you're seeing from that one is that there's a statistically significant, because it's 3 stars, decreasing over that time frame. Once we move into the 2010 to present, all of a sudden we see a less of a decrease. And this is where it kind of gets tricky, is that if we just meshed all the data together, we would see that statistically significant trend, because the last decade, we wouldn't see it singled out. It would be flattened out with the data, and we would show a very statistically significant decrease. But really over the last decade, we're seeing a less of a decrease. And it's just important to note as well as the scales are different on each of them. So where we have a high scale of 60 parts per billion on the older data, we actually have a scale of only 40 on the newer data. So then, just for interest's sake, because Gary wouldn't let me use box plots, sorry, Gary, I had to throw something like this in there. I'm not too sure if people have seen a calendar plot before. So these are ones that we can do as well to actually isolate it for the day. And we can pick any year that we want, and we can isolate it to say what happened in one year compared to another. And we can start to plot it this way. So where you look at it from this perspective, the scale is at the bottom, but it's really the color that you're looking for. The purple would indicate its highest concentration. It's the higher values. And that's what it was in 1990 at Edmonton East. And then we compare it to 2018 when we had the data run for this one. And we see a much lower profile. We can do this for any years. The only problem is that I would have a lot more slides for sure.
Just to let everyone know, Edmonton East is actually located on 17th Street, just north of Baseline Road. So it's sort of nestled in the industrial area. That's actually Strathcona County, but it's called Edmonton East. So just so everyone knows where it is.
And thanks, Gary. There's two stations that have the most history. So Edmonton East and actually Edmonton Central have the longest history. The problem is that Edmonton Central is now changing. It's been closed down. It's still slowly being equipment being removed from it, but Edmonton East is still viable.
They're part of those 8 stations I mentioned that Alberta Environment run, just so everyone knows. Yeah.
So then what we can do as well is that we often say you can get right into the weeds of data in one station, but we have to take a step back and say, okay, what are we seeing everywhere? So this is now taking the ACA data for nitrogen dioxide and comparing every station with each other to see what are we actually seeing. And this data is only run up into last month. And so we've got the history from 2010 up until last month. So we can see where's our monthly trends, what's happening. But the one thing that stands out is that they're all showing a very similar profile. We see that same peak in the wintertime and the valley in the summertime for the nitrogen. And we see it different in certain areas, and we see it more pronounced than others. But it's to give us the ability to look back and forth throughout the zone. Question always comes to it from the other species. So like, for example, our sulfur dioxide and our particulate matter. If anyone asks why I didn't do ozone, it's because ozone does not have an emission profile. So I left ozone out. I have all the data for monitoring of ozone, but I left it out just because of you can't go back and forth that way. So from this perspective for the SO2, you don't see as much of a pronounced pattern from one station to the next. And for the particulate matter, there are certain events that stand out. So during high forest fire events, we see very pronounced peaks that occur, and they stand out for all the data sets. The one thing I was joking with Gary is that some people don't like peaks, and so sometimes the data is removed. And so we've had that in the past where high peaks are removed from the data set. So if you don't see the peak at one station, it doesn't mean that it didn't occur. It just means that it may have been edited out. So after all of that, when we have these poor air quality events, and if you remember the dates that I had with some of the data, and I'm being cynical with some of these, honestly, are we going to wait 2 years in order to find out what happened on the weekend? Nobody wants to do that. So we want this data, and we want it now. Like if you smell something outside, you want to know what it is now. You want to see what's going on. So you have access to some of these data sets. The first one is, of course, through the ACA. You can get onto the website, and we've got the live feed for the data. So you can click on any one of the stations. Gary's got a really good presentation that goes through and tells everyone how to click on a station, the information that you get, and so forth. So there's great detail in that one. But it's just the sense that you can see the data right away and see what's going on. The other one, of course, is the Alberta Air Quality Health Index map. I'm not too sure if everyone's seen that one and gone into that one. That's also live feed data. And so we see immediately where everything lays out from one other station. There's different download capabilities so that you can look at the data, but it's only for less than a year time frame. You can't pull a year's data. Sorry, Gary.
Yeah, a couple of questions came up, sorry. I'll go back to the first one that popped up a couple of minutes ago from Greg King. Why does NO2 have much more of a seasonal or annual/seasonal trend than SO2?
most of the times it's our combustion. Because I give a presentation to a lot of the school kids, and the first thing I start off with is the composition of the atmosphere. And because I had it at the university, where students would tell me that the main component in the atmosphere was oxygen, and I just about died. You know, second year university engineers, and I was ready to strangle them. And so, so nitrogen is our most predominant species in the atmosphere. So as soon as we have combustion occurring, we combust air in a heat source, so we get the NOx species. So any kind of combustion will have the nitrogen species. That's why it's more pronounced. The sulfur species isn't pronounced as much because it's often due to industrial activity. If we flare with high H2S, we'll get SO2. If we have certain activities, certain metallurgic properties, we'll have SO2 emissions. But they tend to be much lower than the nitrogen species from that perspective.
Greg has just responded with a comment that says, makes sense that we see that in the winter, thanks. And then Karen after just supported the first comment, which was, I was thinking the same, suggests that the main sources of these pollutants are different. What is the main source of NO2 versus SO2? And I think you've probably covered most of that.
It's interesting, like for NO2, we tend to turn to that one, but the nitrogen, what we analyze for, it's actually NO2 and NOx. And so it's all three species that we look at. If I'm looking for vehicle emissions, I'll actually tend to look for nitrogen, like NO. If I'm looking for just in general, I'll actually move right to NOx, because that includes everything and it's got a higher number. And we'll see it often in our data where our NO is 1,000 parts per billion, our NOx is 1,000, and our NO2 is 0. And it just happens to be like the weird coincidences for something like that, but it does happen. So I can't remember where I was. Was it here? The Air Quality Health Index. Okay. I'm not clicking on any of these links because I think I would have to stop sharing and share again. But all of these links should be live, even in the deck that you would have afterwards. The next one is for more of a global comparison. So I'm not too sure if everyone has seen the WAQI information. So this one is one that's actually quite interesting. Because I've got a colleague in Abu Dhabi, and he's had questions, and so I'll go and look at some of the data there, and we'll do different conversations on what's going on. So I can do a quick comparison around the world to see where things are and where things are good, bad, or otherwise. I had a slide for the forest fires that we had last May that came through in the Edmonton region, and I took the snapshot off of this website. And where we always tend to see that purple, dark red color in Asia, we actually saw it in our area as well. So it was pretty bad at that time. Then we moved to something like the purple air. And so we also have this one where we can actually get onto the website and look at the purple air, and we can compare this all over the place. So we can compare it from one side to the other and zoom in.
I'm holding one up, by the way, if anyone wants to see what it actually looks like. Yeah.
Has everyone seen the purple airs before? I'm not too sure. And so it's one of those ones, it's a small little instrument, but it's a fantastic for the cost of it. I mean, what you get for data, that's for sure. And I'll talk more about that one afterwards as well. And so after I've bored you with all of that data, the question that we often want to know is, how long do we have to wait to get this information? So I've alluded to it, that we don't want to wait 2 years. We don't want to even wait a year. And I have to say, sometimes in order to get that data, I have to put my academic hat on and use my university email account to say, please give me the data, and I'll get it early. And so I sometimes works. But the question that's always there is, of course, how long can you hold your breath? I mean, we always had the rules of threes. I did my PhD in air quality, and so every focus was on water. And there's lots of focus on water right now. So I often joke to people, you can last 3 days without water, but hold your breath for 3 minutes, see how well that works. And so, but the rule of three is you can also go 30 days without food. So I couldn't, absolutely not. Not working from home. So one of the things that I put in here is air quality actually that important for people, aside from the fact that you need it to breathe, and we don't really consider it. So there's lots of advertisements, lots of news articles over and over again about how important the air quality is. And I find it interesting because it was always one of those ones that you had to fight for information to get this information, but yet we know it's a concern. We know it's an important issue. And Gary talked about that at the very beginning. So our data availability is a big question. And it comes to that, why can't we get it? So when there's a long delay in the data before we get it, what we call it publicly facing, so that you can download it off a website, often there becomes skepticism. What's wrong with the data? What are you hiding from us? How do we trust the data now? Because it's hidden from us. And so what is it that's so bad that you don't want to tell us? It's not necessarily that it's bad or good or otherwise. Sometimes it's just that there's a lot of data to crunch through and get it up to a usable format. And so that's the question, is how rapid can we get this data to the public? We collect data in 30-second increments, if you can imagine. So there's a lot of data that gets sifted through to see how things are going. And so the big one that we talk about is that with all of this data that's out there, what about this whole citizen science thing? Is it actually something that's real, or are people just making it up? It's real. And so I worked in government for 10 years, and this is one of the things that we really pushed for. We really had a push for citizen science. We wanted to spread this information out for a lot of people. It's quite funny, I had my wife look over this presentation, and one of the things that she pointed out, working in government as well, is that it's too bad the US EPA's citizen science air monitoring document is so close to scam. Because she goes, it's so easy to see it that way, but it's not. It's CSAM. But they really should have thought their acronym through before putting that one out. And so, but the European Environment Agency, like the EU, has their citizen science program. The US EPA has a whole bunch of information for citizen science, and not just for air, for water, for soils, there's a whole bunch of things. And then, of course, both Gary and myself have worked with the Meteorological Society of Canada in order to talk about the small citizen science projects, like the Purple Air.
Maybe I'll just jump in, give you a chance to catch your breath. I had a little slide at the beginning about what is an airshed. You might be interested to know that the airshed model is a made in Alberta model, largely around transparency of data. So we can go back to see some events that occurred where there was some significant releases of chemicals, and the public were not informed, and the public had no access to data. So it was a combination of too little monitoring, and what little monitoring occurred, it was kept either by industry or by government, and then messages were determined after that. So the concept was, if you put all the stakeholders together and have this sort of tenet of open data, it wasn't called that at the time, but it's really what it is. We have a sort of tenet of anything that we do should be public facing. That helps, so that all stakeholders have the same access to the same data, including the public. So I just thought I'd throw that in. Back to you, Kevin.
No, that's perfect. And if everyone's aware, that's the lodgepole blowout that Gary was talking about in particular. So everyone remembers that one. Although that's hard to explain at a university class when most people are born well after 1986. And so this is one of the things that's come up because governments are responding to this quite well. So there's the conversation that we have these smaller monitors, these inexpensive monitors that we can use, but it's not that fixed reference method. So governments do not want you to use that. And I want to say, don't want to use it for compliance purposes. Understandable, because you want to make sure that you're doing things according to the legal definition of what's going on. But the US EPA has stretched this one where they're starting to now indicate different tiers, and the EU is going the same way. So you now have smaller instruments that you can use, the indicative, and all the way up into reference methods. And they'll give a tier of qualification to say these indicative methods are plus or minus 20%, where the reference method should be plus or minus 5%. So they'll give that classification for it. But as we see as we go through, some of these small instruments will surprise you for where we get. The evolution of the monitoring that's going on, and this is where Gary said I kind of geeked out with some of these things, is that there's been a rapid need for people and information. So some of this has come from Asia because of where the air quality was so poor. And there was just a need for quick access to information and quick and I mean quick to get onto your phone so that you can have that. The other thing is that the public wants to be more involved with this information. And that was one of the things that we really talked about in government as well, is that the public has the pulse of social media. Government doesn't. And so, like, Gary can tweet like I've never seen before. And so, but I mean, the citizen science thing becomes more important, and it's something that we definitely want to support. And some of the adage that we've always seen for the airsheds is that we cannot manage what we don't measure. And that's where it comes into some of those gaps that we see. It doesn't mean that the air quality is clean in those areas. It just means that we're not monitoring in those areas. So without that information, there becomes some questions. What's actually going on in that area? Does it mean that we're missing something? I can smell something. There's something wrong. So that's where it comes into some of those. But where we're seeing this move is that you're taking these blue box analyzers from like on shelves, and you're condensing it down into essentially nanosensors. So we're getting these sensors that are really extremely small, handheld. I mean, extremely small sensors like the Plume Labs, the flow analyzer. I mean, you have all sorts of ones like these things that are coming out now. And really one of the things that we talk about is that there's a great advantage of these ones, the small instruments, because they're portable, easy to use. And I don't know if everyone remembers this incident that happened. I do remember this. And it just so happened that we had recording of something like this happening. So the biggest upset for me of this whole thing was that spider actually got away. And so I did not kill it. It actually got out of the instrument. And I'm sure it was radioactive by the time. No, I'm just kidding. And so, but didn't help. Oh, and so now we actually move into some of these new portable systems that are out there. So the Purple Air, Gary showed you, the flow was there. We have a small VOC sampler. We've got tiny particulate, do-it-yourself particulate analyzers. It's for a school project with the Raspberry Pis and things like that. You could make some really tiny particulate monitors, and they're really neat for doing that. I had to throw in the UAV as well because those are really cool, like the Flying Lab. It's quite an interesting one. But there's a whole bunch of these different types of analyzers, and I'm not going to step through each one of these, but there's advantages with going some of the smaller instruments, because to put a station on the ground could be upwards of $250,000 to $350,000 to put a fixed reference method sampler onto the ground. To put something like a Purple Air on the ground, Gary, what was the Purple Air's worth?
Yeah, $300 we pay. So we paid $350,000 for a station. We paid $300 for a Purple Air. Yeah.
So, and those are the kind of things that we start talking about when we start looking at some of these other instruments. Because, for example, with forest fires, we want to deploy a whole bunch of instruments that we can measure. It makes it very costly. So when Manitoba deployed a whole bunch of analyzers, 4 in particular, they put them out into an area. They were $15,000 each. They weren't well taken care of. I mean, mostly because they were deployed and left. Where a Purple Air is put out for $300, it's a little more palatable if that thing breaks down. And so.
Sorry, I have some questions. Sorry, boy, I keep saying I'm going to watch this and I don't. So I'll go back to, okay. So Julie and Matt are talking about the walk on Saturday. Then I think we have the next one is Sandra. Where does Purple Air sit on the tier? Oh yeah, the EPA tier.
I'll back it up a bit. Where's our tier? It would come down into the indicative samplers, the 1 and 2.
Yeah.
That's where they have it right now.
Yeah.
But
yeah.
That's not where it really sits in reality.
Yeah.
And so they have it there mostly because of the cost. And so, and I'll show you as we get further on.
But what's interesting to know about Purple Air is not, it's being used quite extensively. The government of British Columbia has hundreds. Health Canada has thousands. California's been using them for years. So they're really quite used. Okay, so next question, sorry. Karen's question is, are the percentage SD meaning based on SD, or how is it calculated? Which slide were we talking about? Sorry, so far back.
You were paying attention to the questions.
I was watching your entertaining show. I'm sorry.
I'm trying to think of back.
Kevin, I know I get to hear it daily, but I still like to hear you speak.
I'm going back to see, but I'm trying to think of where there was a calculation. No, that's too far back.
So this was the same slide that you just were on before, where you're talking about the precision of various different types of air monitors based on a percent. So the question is this based on, like, I assume this is an acceptable percentage for that particular category. So the question is this based on like plus minus 50% based on standard deviation, like something we see a lot, or is it the extreme values, like you can get, shall we say, errors of up to 50% of the real value, or is that a typical error? Like how do we calculate those errors? What do they really mean?
It's a comparison based on a reference. So for example, if you give a reference gas or a reference particulate into it, so it'd be a filter that you would put in and say, this is a known reference at this level, and this is what you should be reading. So the numbers in here where it says 50% all the way to 10%, I've seen different variations of this. The reference is typically down to about 5% now. So that means it has to be within 5% of the actual number. So if here's the reference that you're given and the number is 10, you have to be within 5% of that 10 in reality.
So, but do you take like, say 20 samples, 20 reference samples, and then you average it out and you see what's the standard deviation there? Do you just take one sample and say, okay, it's only 10% above what we think it's going to be, so life is good? Or like, how does that work exactly?
It's based on a calibration. So when they do a calibration, you give it that reference value, and then you look at what the response of the instrument is, and you typically run it for about 10 to 15 minutes, 15 to 20 minutes, if it's not operational, and it has to settle out within that time frame to get that number. So there'll be multiple readings in that time frame. So if you're collecting 30-second increments and you run it for 20 minutes, you'll have that many readings to see, and it has to be within that number at that time.
Okay, so is this just a single sample, like a single sample of a reference air?
That's correct.
So you don't really know whether it's always going to measure, say, 10% above, or whether on average the sampler is going to, you know, average out on around the right value, but there's just some variation around the right value, or how exactly it's off.
If you humor me for just a few minutes, I think your answer may be answered in a few slides.
Okay, perfect. That's
and then we can touch back on that one as well.
Yep.
Okay. Any other questions?
No, we're good.
So, I got lost again. Oh, back to this one. So when we start looking at some of these different monitors, the one thing that's nice with the purple air is that now we can actually pull all this information down. So it may be a little bit hard to see, but all the little red dots on here are all the purple airs collected within the Alberta Capital Airshed. So there's actually quite a few of them, not just the ones that we've put out from the Airshed, but there's also a bunch of others. And so me being the data, what was it, the data dweeb or data geek or whatever? There's a whole bunch of names for me. You'll start to look at all of these different stations and just start melding them together and see what the data starts looking at. So this is the same kind of thing where we'll actually have the information, and then what we saw from the purple air map, it would actually have the number on the circle of where the values were. I tend to favor the heat maps, where it's like I'll put the dot where the location is, and then I'll actually put the heat map to show where they cluster together and see where we actually have some hotspots. When we start to look at the purple airs, one of the things that we wanted to do is co-locate them. So taking these citizen science monitors and start putting them and comparing them to an actual reference method to see what do we actually get from something like this. US EPA has done this for some time, and they've done it through many states to try and put it together. So what they found is from their evaluation, they were actually having a decent fit for some of their data. based on a correction. So they were getting an R squared of about 0.7. And with that, they came up with an equation that takes into consideration the reading from the purple air, the temperature for the purple air, and the relative humidity. And then feed that into the equation, and then you would get essentially corrected value. So Karen, that would be like your calibration to say, how are we actually fitting on this? Here was the reference, was the fixed reference method, and we're comparing that to what the purple air picked up. And then we're doing it over time to see what's going on. So US EPA evaluation came up with this one. There's been question that there's a guideline right now coming out from Alberta Environment and Parks. So we wanted to go ahead and take a look at some of our co-location. So one of them was Woodcroft. And so you can see from the fit from the purple air that we have and the actual PM 2.5 that's measured, we were getting quite a good fit, about a 0.9 R squared. And the corrected equation that we have isn't far off of US EPA's. It was actually fairly close. And all this was a multilinear regression that's done on the data to see where we can fit it the best. We also did it for the McIntyre Center. So this is pretty much the McIntyre Center is kind of the center of excellence for Alberta Environment and Parks for a lot of particulate studies. So it's something we've done lots of work with there. And again, the corrected equation that's come out from that one, it's not far off of US EPA's. There's a few outliers, like you can see from the data. There's odd outliers that come out of the data. We could throw those ones out just because it's outliers, or we can leave it in there just because this is what we measured. This is what the fixed reference method sample came up with. So this is how we're trying to do the correction to see if we're actually getting the proper data and how close we're getting. So now to put that into perspective, we have a $30,000 particulate analyzer in the reference method, and we have the $300 purple air. And this is our fit that we're seeing. So from a citizen science perspective, we can see all that. And there were concerns, like the government was concerned in different levels, saying that what happens if a whole bunch of people put out these purple airs and then all of a sudden the environment gets inundated with calls. My purple air is at 200, what's going on? You know, all sorts of questions like that. So there was concern that essentially we're behind. We have to get caught up on some of these things. And that's from a government perspective. I think I talked too much, Gary.
Okay, I'm going to jump in. I have just a few slides talking about citizen science. So to build on what Kevin was saying, I would offer that citizen science has not always been embraced by the authorities. And there is some legitimate reasons, I think. So you can go buy a device off the internet. There's a whole bunch of different choices. And you can plug it in your house and you can look at it, or you can wear it, depends on the kind of device. And it's really good as a personal sensor. Most of them, some I guess are not good, but the ones that have some rigor behind them are great for that. But then many of them will say, stream the data to our website. It's fine. Purple Air is a good example. Where you run into troubles is when there's 3 of those devices in a city of 1 million people, and that website is suggesting that that is the air quality for that entire community. So there's a number of companies out there trying to broadcast air quality, which may not equate well with our reference methods. So I think that's where we have a bit of challenge with devices. And I think where an Airshed plays a role is what we're doing tonight, which is connecting traditional monitoring with community engagement and citizen science. And these don't have to work in opposition of one another, and one can inform the other. So traditional monitoring has gaps. It's more regional. It certainly doesn't get into the granularity of neighborhood level. And this is where we get a bit excited about this, about saying, well, let's put this down. So Kevin, next slide. And so this is just from a poster that we have where we're trying to recruit host sites for a couple of different devices that we're using. One is Purple Air and the other one's just what's called a passive. I'll explain that in a second. But we wanted to make sure we had a good network around our Airshed in addition to those expensive stations that we run. And then we want to go further. So I think we'll just move on. There'll be a picture probably next slide. Yeah. So there's a Purple Air of the pictures you're seeing. Sorry, the top left is a Purple Air on the side of my house. On the top right is the size comparison to a coffee mug And so that is an electronic sensor that does fine particulates. It'll stream it to the Purple Air website worldwide, which is really cool. And you can see it. You can also, in the index in the bottom left of their worldwide Purple Air site, you can choose Canadian AQHI. So it's not exactly, it's only one parameter. It's not true AQHI, but it's sort of interesting to see your device at your house and how that compares around the world. So I have to say, it's pretty good. So that's one, Purple Air, because it's good for particulates. And then the bottom right is what we call a passive shelter. So in there are filters that will absorb parameters or pollutants for the course of a month, and then we take that in, we'll have a laboratory analysis done to see the total amount of that pollutant over the course of that time period. And so it does not tell you trends during the day or trends during the week, it's just a total amount during that month. They're helpful, but it has limitations for sure. The nice thing is you don't need electricity or Wi-Fi. And the bottom left picture is just actually the community of Riverdale, where there's, you can't see it probably, but there's a little passive hut on that pole by the ice rink. You might be interested to know we're actually putting up Purple Airs this month at city rec facilities. The city of Edmonton, which is one of our members, asked us to do it because of wildfire planning and COVID-19. The connection between bad air quality and COVID is linked quite strongly. That poor air quality would be hard for those people recovering from a respiratory disease like COVID. So the city's COVID task force has looked at the concern about wildfire smoke, which with all the rain may be less of an issue now. But that's, so we're putting those up in rec facilities as well. Kevin, next slide. Okay, so, and then this is a different device that we've just got. It is a wearable air quality monitor. Plume Labs is a company out of Paris, and this is called the Flow. We have, this is a second iteration or version of their device. We had the first one, we played around with it for a while, and it was quite interesting. The second one actually is quite good. We're very impressed. We waited a little bit to see some academic rigor on it, and we've just got possession of 8 of them last week. So 2 have gone out for sort of reference testing, and then so we have 6 in our hands, and they monitor NO2. Actually, I have one right in front of me. There, that's mine. So they monitor NO2, VOCs, and particulate matter 1, 2.5, and 10. And again, we're mostly focused on 2.5. And so it's pretty cool, I have to say. And we are going to be loaning these out to some of the groups that we work with. And we hope to get more of them and additional devices, because we're also interested in some communities around the issue of H2S, like wastewater treatment and really smelly compost facilities in the west end of Edmonton, places like that. So, but it's a really good, I think, where the Airshed can help with some technology, some expertise, and community groups can provide the boots on the ground, or whatever the expression is, and we can work together on collecting some additional data at this sort of neighborhood level. So I think this is what we're going to be working with in the Tomorrow Foundation's pilot in Queen Alex.
Sorry, Gary, I just wanted to add in, the Purple Air, we've been talking about it as for PM 2.5, but it also does the PM1 and PM10, but we hardly do, well, we don't do PM1 monitoring, and we hardly do PM10 monitoring. So the only thing that we can actually then do a comparison in, like that reference check, is PM 2.5. And so that's, but it does do all the different size fractions as well.
Right, right. So we do have a, and I think it was in the comments from Julie and Matt, we have installed a Purple Air in the Queen Alex neighborhood. And if you join, I'm going to do the sales pitch here for you, Julie. The Queen Alex, are you going to do the tour on Saturday? The walking tour, you get to see it, which will be exciting. So I shouldn't show the one I have behind my head again. But anyway, so yeah, and we will likely, we're putting more up all the time. These are great little devices. And so there's nothing once it's put up, you don't have to do anything with it. and you can buy these off the internet, by the way. Purple Air, you can just buy one, you can set it up. If you talk to us, we can actually stream it on our website as well. If you choose not to do that, you can just do it on normally. So there's no control around that, and I think that's great. But we're encouraging people to work within the Airshed just because we hope that we can collect more data and try to connect data so it doesn't become disparate and or challenging one another. I think that's, probably just one thing with devices like this. When we work with community groups, volunteers will have to understand there's some privacy issues. These things track your movement. So, and we will, if you upload the data to us, we know exactly where you've been and when. Obviously, we're not interested in anything other than correlating where you've been and the air quality of where you've been. But I know because it comes out of France and there's some strong EU requirements about privacy, you have to go through some hoops to be able to share data with us, just to let you know. But I promise you, we really don't care where people have been. We're not connected with some big agency. We are, though, interested in the air quality. So back to you, Kevin, I think. Next slide.
Well, it depends on the time. I don't have to go into any more. I can just cut it here. Julie, it's up to you.
I think we're kind of done of time, aren't we?
Are we out of time?
We probably are. We always do this.
So I think maybe what we could do is maybe spend the next 5 minutes on questions and then invite whoever would like to stay for the second half of the meeting to stay on, be part of that meeting, and hopefully, you know, get a few more questions answered either by yourselves or by the Tomorrow Foundation pilot project. So go ahead. Any other questions for our presenters? Okay, well, I want to say thank you for coming out tonight and doing this presentation. I have learned a ton. So thank you for that. And I'm really looking forward to working with Alberta Capital Airshed on this pilot project as we move forward. And it looks like Karen's going to squeak in one more quick question as I'm wrapping up. So go ahead, Karen.
I just didn't want to take the question time if other people had questions, because I have been asking enough already. I was just a bit curious about the choice in monitoring devices. So when you were talking about the sources of the pollutants, you were talking about how NOxes are more something we see in association with combustion, such as cars or heating houses or whatever. SOxes are more something we see in association with industrial pollution, and particulate matter was more something that we see in association with forest fires. So if the research question of this citizen science project is how air pollution varies with a change in car density, then why are we mainly basing it on a device that measures particulate pollution, which sounded like it was more of a forest fire indicator rather than a device such as the wearable one, which I presume could also be used as a non-wearable one that you hang somewhere, that measures the NOxes?
Good question. I'm going to start and I'll turn it over to Kevin, but just to say it was my influence actually to add fine particulate monitoring to the pilot, because traffic does affect PM as well. So PM, it really comes from all sources, and it looks a little different depending on the source, but traffic does. Traffic dust does, traffic exhaust does, car brakes affect PM. There's many implications to that. So the original pilot, as I saw it, was focused on NO2, but I think I wanted to add PM to it. And so that's the first half of my answer. My second half is we've just put up one device. So we are going to be working with the Plume devices. And the passive actually that we've installed also in Queen Alex is for gases as well. So we haven't, in other words, we're not weighting it too heavily on fine particulate matter. Kevin, do you want to add anything to that?
Sure. The particulate does actually measure the traffic pattern as well. But often what we'll find is that when we start to see the influence of the traffic on the particulate matter, we tend to move those stations because all we're seeing is traffic. So I've got data from history where we've had different stations in Edmonton and Calgary in particular. And it was kind of a humorous study at the university where we could tell you exactly, and this was using particulate matter, of which was the capital cities in both Saskatchewan and Alberta, because in Regina and Edmonton, we found the spikes would occur for rush hour traffic at 3 to 4 o'clock on Fridays. And in Calgary and Saskatoon, it actually occurred at 4 to 5 o'clock, indicating that governments tend to go for a beer at the end of the week. And so, and we correlated that with data, you know, because we saw all the people going for beer. So,
I'll go for beer.
but the particulate Edmonton Northwest Station was in particular. It was a perfect tracker for vehicles. We could see it very clearly, and we ended up moving that station. Well, the federal, like that one was moved because of NavCan. They wanted it off their property, but it was an excellent one for particulate traffic, because you could correlate rush hour traffic perfect with it.
Okay. Thank you.
If it's possible, Julie, I wanted to share just one thing more.
Go for it.
I'll just flip it back up here. There is one of the last things that I talked about, new sensors, and you can have the deck, that's for sure, is tracking everything via satellite now. So we can definitely do things. Can you actually see that?
Yes.
So we can now track a lot of these forecasts through satellite links. And in the slide presentation for about, I think I've got about 4 different links on there where you can go on and see daily satellite feeds. You can click on and take a look at the satellite tracking of various, like Copernicus, Landsat 8, things like that. The Sentinel-2, all different ones that measure a whole host of different surface pollutant parameters that you can start to measure. And this is one of the ones that where we talked about there's gaps in it. I'll take a look at the entire province. In fact, we'll take a look at the entire Western Canada in a swath just to see how things compare with one another. And we can do that snapshot pretty quick and pull it up from the satellite feed. And this is just an example of one of the feeds, and I've got the link in the presentation. And the cute thing about this one, the nerd thing about this one, is you can go to different pollutants. And so if I want to go, what is the SO2 at the surface? This is the profile of SO2 currently. And we can see where the track is from the wind profile, and we can start to track it and see where things are moving. And this is fairly real time. That's the one thing with the satellite feeds, as we've seen technology jump. We've now got near real time satellite feed for some of this data. We can go 24 hours right now.
So I think our opportunity and challenge is to try to integrate all the different data sources so that we know as much as we can about the ambient air that we're breathing.
Yeah. It's very mesmerizing. I sometimes have this up and I just watch it because it's neat to watch. And so
only Kevin would do that.
Well, wonderful. Thank you. Thank you again. This I'm just watching that chat, and people are posting all sorts of great comments. So I do hope you know, you're able to stay on for the next little bit, and people can continue to ask you questions. And thank you to everybody else who came, and I do invite you all to stay for the next part of our meeting. At this point, though, I will ask Russ to stop the recording, and we will conclude this section of the evening.